Did you know the moon isn't as quiet as it seems? Shocking statistics reveal that since 1969, NASA has detected thousands of unexplained tremors on our closest celestial neighbor. What deep geological secrets are hidden beneath the lunar surface? And why do these moonquakes continue to baffle scientists decades later? Prepare to uncover the unsettling truth about our enigmatic moon. Before we go any further, make sure you watch until the end, because the final discovery we will explore may change the way you think about the moon forever. And if you enjoy learning about the hidden science of our solar system, subscribe now so you don't miss the mysteries still waiting to be uncovered. From Earth, the moon appears timeless and still. Hanging in the night sky, it drifts through its monthly phases without a flicker of change immutable to the naked eye. For centuries, people imagined it as a dead, silent world, long since cooled into geological dormancy. But in the closing years of the 1960s, when human beings first set foot on its surface, we discovered that beneath its calm exterior, the moon is far more alive than anyone expected. The Apollo missions were not just giant leaps for humankind, they were profound scientific expeditions. Between 1969 and 1972, Apollo astronauts deployed an array of instruments on the moon's surface. Among the most important were seismometers, designed to listen for vibrations in the lunar ground. These devices, set up by the crews of Apollo 11, 12, 14, 15, and 16, were linked to Earth via radio transmissions, sending back years of continuous seismic data. NASA scientists anticipated they might detect the occasional vibration from a meteorite impact. What they found instead was extraordinary. The moon was trembling, regularly and for reasons that were not always clear. The data revealed not one, but several distinct types of moonquakes. Over the years that followed, more than 12,000 seismic events were recorded. Many were small and harmless, but some were powerful enough to rival moderate earthquakes on Earth. The surprise was not just in their existence, but in their persistence. The moon, it seemed, was far from geologically silent. One category of these events occurs deep within the moon's interior, hundreds of kilometers below the surface. These are known as deep moonquakes. They are remarkably regular in timing, occurring at specific points in the moon's orbit around Earth, repeating in cycles that align with the pull of our planet's gravity. The leading theory is that these deep quakes are caused by tidal forces. Just as the moon's gravity raises tides in Earth's oceans, Earth exerts a tidal influence on the moon itself. Although the moon is solid, not liquid, this immense gravitational tug subtly stretches and squeezes its interior. Over time, the stress builds until the lunar rock adjusts, producing a quake. NASA's analysis of Apollo seismic data found that these deep moonquakes originate roughly 700 to 1,200 kilometers beneath the surface in the moon's mantle. They are relatively weak, typically equivalent to a magnitude 2 earthquake, but their regularity is astonishing. Certain moonquake sites would produce tremors at almost the exact same time each month, like a slow and steady heartbeat deep within the moon. A different kind of moonquake happens much closer to the surface, known as thermal moonquakes. These are triggered by the extreme temperature changes the moon experiences over the course of a lunar day. A day on the moon lasts about 29.5 Earth days, which means 2 weeks of relentless sunlight are followed by 2 weeks of frigid darkness. In sunlight, the surface temperature can soar to over 120 degrees Celsius. At night, it can plunge to minus 170 degrees. When the sun rises after the long lunar night, the rocks on the surface expand rapidly as they heat up, creating stresses that cause them to crack and shift. These thermal moonquakes are generally small and shallow, but they occur with predictable timing, tied directly to the cycle of day and night. Both deep and thermal moonquakes can be explained by well-understood physical processes, but the Apollo data also revealed a third type that is more puzzling. These are the shallow moonquakes, and they are by far the most mysterious. Shallow moonquakes originate less than 200 kilometers below the surface and can be surprisingly strong, reaching magnitudes of up to 5.5 on the Richter scale. That is powerful enough to move large structures and would be felt intensely if you were standing on the surface. Even more unusual, the vibrations from these shallow quakes can last for astonishing lengths of time, sometimes more than 10 minutes. On Earth, seismic waves are dampened relatively quickly by the planet's fractured crust and softer layers. But the Moon's crust is dry, rigid, and less fractured, allowing seismic waves to reverberate for much longer. The cause of shallow moonquakes is not fully understood. They do not seem to follow the regular cycles of deep quakes, nor are they directly tied to the temperature swings that drive thermal quakes. Some have speculated that they could be related to the settling of the Moon's crust after billions of years of cooling. Others suggest they may be linked to tectonic-like activity, as the Moon's interior slowly contracts. NASA's Lunar Reconnaissance Orbiter has mapped thousands of small fault lines on the Moon's surface, scarps that appear to be geologically young. Some of these faults may still be active, and the stress along them could be released in the form of shallow moonquakes. The mystery deepens when you consider that the Moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. This gradual separation slightly alters the tidal forces between the two bodies over long timescales, potentially changing the stress patterns in the lunar crust and mantle. While the effect is subtle, it is another factor that may influence the occurrence of moonquakes. In addition to these naturally occurring events, the Apollo Seismic Network also recorded artificial moonquakes. These were generated when spent rocket stages and lunar modules were deliberately crashed into the Moon at the end of missions to test the seismometers. The vibrations from these impacts confirmed that the Moon rings like a bell, with seismic waves traveling long distances and persisting far longer than they would on Earth. This ringing quality is not a sign of anything hollow or artificial. It is simply a product of the Moon's dry, rigid structure. The Apollo seismometers continued to operate until 1977, sending back an unprecedented treasure trove of data. But with their shutdown, our ability to monitor moonquakes in real time came to an end. For decades, the mystery of shallow moonquakes remained unresolved, with scientists relying on the old data to piece together their origins. The lack of new seismic measurements has been a major gap in our understanding of the Moon's interior. That gap is now poised to close. With NASA's Artemis program planning to return humans to the Moon, new seismic experiments are on the horizon. The Artemis missions, along with the Commercial Lunar Payload Services program, will deliver advanced seismometers to multiple sites on the lunar surface. These modern instruments will be far more sensitive and capable than those of the Apollo era, able to detect smaller quakes, pinpoint their locations more accurately, and measure the Moon's seismic activity over a wider area. By deploying multiple seismometers across different regions, scientists can triangulate the sources of moonquakes with greater precision, building a more detailed picture of the Moon's internal structure. This will not only help solve the mystery of shallow moonquakes, but also inform future lunar bases. Understanding where and how often strong moonquakes occur will be essential for designing structures that can withstand them. The importance of this research extends beyond engineering. Seismology is one of the most powerful tools for probing the interior of a planetary body. On Earth, seismic waves have revealed the layered structure of the crust, mantle, and core. On the Moon, similar studies can tell us about its formation and evolution. For example, we know from Apollo-era data that the Moon has a small, partially molten core surrounded by a mantle of varying composition. But the details remain uncertain, and new seismic data could reveal whether the core is larger or more complex than we thought, or whether there are regions of partial melt within the mantle that influence moonquake activity. Moonquakes are also a reminder that the Moon's story is still being written. It is not a dead relic of the solar system's past, but an active world shaped by forces we are only beginning to understand. Each tremor is a whisper from deep inside, carrying clues about the stresses and structures hidden beneath the surface. In the years to come, as Artemis astronauts set up seismic stations and robotic landers deploy instruments in regions never studied before, we may finally answer questions that have lingered since the Apollo era. What causes the most powerful shallow moonquakes? How do tidal forces and thermal stresses interact with the moon's internal geology? Could there be processes at work that we have not yet imagined? Until then, the moon will continue to tremble in its quiet way, unseen from Earth, but recorded in the data we have gathered. It is a reminder that even our nearest neighbor holds secrets. The same moon that has inspired poets and guided travelers for millennia is also a place of hidden activity and subtle motion. Its surface bears the scars of countless impacts, yet beneath that surface, it pulses with energy from forces that have not gone silent. Standing on the moon during a shallow moonquake would be a strange experience. There is no air to carry sound, so you would hear nothing, but through your boots, you would feel a faint, persistent vibration, like the hum of a distant machine. The ground might shift slightly, then settle again, leaving no visible trace. And yet, that moment would connect you directly to the deep interior of a world that still moves in ways we do not fully understand. The moon is a place of contrasts, still yet restless, cold yet shaped by the heat of the sun, familiar yet mysterious. The discovery of moonquakes shattered the old image of a geologically dead world and replaced it with something more dynamic and intriguing. As we prepare to return to the moon, we carry with us not just the ambition to explore, but the tools to listen. And when we listen carefully, we may find that the moon has been speaking all along, in the language of tremors and vibrations, telling us the story of its hidden heart.